In this video lesson, we're going to be looking at polyatomic ions. So remember that an ion is anything that carries a charge. A positive ion is called a cation, a negative ion is called an anion. And where we have seen most of our ions, for example, is maybe when we are looking at like a sulfur ion that has a charge of -2. And we know that it has a charge of -2 because it is found because of where it is located on the periodic table. So a sulfur atom will gain 2 electrons to get a negative charge. This is just a regular ion. Now, there's another type of ion, and this is when you have a group of nonmetals that are bonded together. And together, when they're bonded together, they carry an overall ionic charge. So this ion right here, this is a sulfide ion. But sometimes we have a sulfur, and that sulfur is going to be bound to 4 different oxygen atoms. So when that sulfur is bound to 4 different oxygen atoms, sometimes the whole thing has an ionic charge. So in this case, this whole group of nonmetals has an ionic charge of 2 negative. Because it's no longer just a plain sulfur atom with an ionic charge, it's a group of nonmetals. It's not called a sulfide ion, but it's called a sulfate ion. So when we have just a single atom with an ionic charge, it gets the ending IDE. But when you have a group of nonmetals bonded together, it gets the ending ate. So there's a few things that we should know when we're talking about polyatomic ions. The first one is that they're also called radicals. So you might see that word used to describe them, radicals. Okay. And what I said already, they are a combination of nonmetals that are bonded together and carry and have an ionic charge. Now, the important thing to note here is that the ratio of the nonmetals bonded together always stays the same. So this sulfate ion up here is always 1 sulfur and 4 oxygens. That's really important to remember, that the ratio of the atoms bonded together again, that are bonded together, never changes. The only exception is that this is, of course, unless it undergoes a chemical reaction. Then if it undergoes a chemical reaction, it's something new and it's going to have a new name. The other thing to note about our polyatomics is that because they carry a negative ionic charge, is that they can bond with a metal to form what we call a polyatomic compound. And finally, our polyatomics end in the suffix ate, like we've seen above in that sulfate, instead of ide, like we've seen before. And this is but there is an exception to this. And that exception is hydroxide. Okay, so now that we know some general information about polyatomics, I'm going to introduce you to the polyatomics. So I like to call them the eights. Okay, so these are the eights. We have carbonate, phosphate, chlorate, fluorate, bicarbonate, nitrate, sulfate, iodate, bromate, and hydroxide. All of them are a group of nonmetals bonded together that carries an ionic charge. So this is a -2 here. Okay, so make sure you pause this and you get the eights copied down. The eights are really important for us to be able to recognize. In fact, if I were you, I would probably actually memorize these. Or be very, very familiar with them. So once you're done copying, just unpause the video. So learning the eights can be a little bit challenging to start with, but once you use them frequently, you will just kind of know what they are, just like you know how to spell common words because you write them very frequently. But if you take a look at the periodic table that I've given you, so looking on the alkane periodic table of ions, if you look here in this table of complex ions, what you can see is that most of the polyatomic ions are here for you. There's bromate, there's chlorate, there's nitrate, iodate, phosphate, sulfate, I think carbonate. Oh, yeah, carbonate's here as well. And then there's some other ones that look kind of odd to us. We're not going to talk about them today, but they are in the table of complex ions. There's something like chromate is here, or silicate. They're all right here for you. So take a minute and highlight these eights that I've shown you on your periodic table. That way you can find them really easily. All right, now we are going to jump in and we're going to talk about how we can write formulas for polyatomics. When we write formulas for compounds containing a polyatomic, we just follow exactly the same rule we've used before. We use the crisscross rule. So here's an example. We're going to find a formula for calcium, spelled that wrong, phosphate. So our crisscross rule is you write the symbols, so calcium and phosphate from your periodic table you know is PO4. You put the ionic charges on top. So calcium, we know, has an ionic charge of 2 plus, and our phosphate has a charge of 3 negative. And then we just cross them down. And if we do that, we get Ca3 and then PO4 and a 2. The problem is if we leave our formula to look exactly like this, it looks like our compound has 3 calciums, a phosphate, and 42 oxygens. We know it doesn't have 42 oxygens. We know that it's going to have 2 of the phosphates. What we have to do is indicate that the 2 belongs to the phosphate as a whole. So we put a bracket right around the polyatomic. Okay, so just make a little note that when you have more than one in the compound, you use a bracket to indicate that there's 2 of everything inside the bracket. So if we do another example, this time we'll do sodium hydroxide. So we're going to use our crisscross symbols and charges. Sodium has a charge of +1. And hydroxide on your list is OH and a -1. We cross them down like this, and we end up with NaOH. Now, in our last example, we used a bracket to indicate that there was more than one polyatomic, but I want you to note that right here, we don't have a bracket. This is because the rule is that we do not use a bracket when there's only one polyatomic ion in the compound. Our next example, let's look at, we're going to do something that has a multivalent metal. So our multivalent metal, actually a backtrack, we're going to do a lithium chloride first. No, not a chloride, a chlorate. What am I doing? So a super quick crisscross is showing that lithium, it has a charge of +1. And on our periodic table, our list of 8s, our chlorate has a charge of -1. So we're going to drop the signs and we're going to cross our numbers down. So this one is nice and easy, LiClO3. And again, we are not going to use a bracket because there is only one of the chlorates. Now we'll do that example with a multivalent metal. We're going to go copper 2 sulfate. So symbol of copper, ionic charge is 2 plus because it has the Roman numeral 2 here. And our sulfate, in our list of 8s, it is SO4, and it has an ionic charge of 2 negative. So this 2 is going to cross down here, and this 2 is going to cross down here. So we end up with Cu2, SO4, 2. We should have a bracket here because it's telling us that there's 2 of the entire sulfate. But if you notice, they both have a 2. So we can put that into lowest terms where we don't need a bracket because there's only one. So we still put in lowest terms. All right, now we've looked at how to write formulas for polyatomics. We are going to look at how to name polyatomic compounds. So we have a couple rules for naming polyatomics. These are kind of just little steps. The first step is exactly the same as naming other ionic compounds. We write the name of the metal first. The second step is something else we already do. We have to check for a multivalent metal and add our Roman numeral if we need it. And our third step is that we just write the name of the polyatomic ion with the proper ending. So let's look at an example. We'll look at the first one. We'll look at the formula Zn bracket NO3 bracket 2. So when we go to name this, we are going to write the name of the metal. So Zn is zinc. We're going to check, do we need a Roman numeral? No, zinc is not multivalent. And then our next step is to write the name of the polyatomic. NO3 from your list, that is nitrate. So this is zinc nitrate. Our next example, we're going to do AlPO4. So we look, we have the name of our metal. Al is aluminum. And then PO4 on your list is phosphate. Just going to scroll up here. Let's look at PB bracket ClO3 bracket 4 to name. So we look, PB is lead. So we have our name of our metal. We do a quick check. Is lead multivalent? The answer is yes. So we have to do a reverse crisscross to figure out the ionic charge of our lead. So this 4 comes up here and it's 4 plus. And the invisible 1 here is going to come up here and be 1 negative. You have to do a quick little check to make sure your charges are right. 4 plus is an option for lead, so that's good. And chlorate has an ionic charge of 1 negative. So the charges line up. So this means that this is lead, Roman numeral 4, and then ClO3 is your name of your polyatomic. So this is lead 4 chlorate. Let's look at one more example. We're going to look at CuSO4. So our steps, we find our metal, it's copper. We're going to recognize that copper is multivalent, so you need to do a reverse crisscross. Now, be really careful here because you just need to make sure that you don't accidentally reverse crisscross this 4. This 4 is attached to this oxygen. So it's not the 4 that's going to reverse crisscross. It's the invisible 1 right here. The invisible 1. Sorry, it's this invisible 1 right here that we're going to cross up to our copper and give that a 1 plus. And then it's the invisible 1 here that's going to cross up here to say that sulfate is a 1 negative. This is where knowing your 8s comes in handy because you have to do a little check to make sure the ionic charge of the sulfate is correct. And if you look, the sulfate does not have an ionic charge of 1 minus. It has an ionic charge of 2 minus. So you have to multiply all of these by 2 to give sulfate a 2 minus, and the copper becomes a 2 plus. So what this means is that copper's Roman numeral is actually 2 plus. So this is going to be copper 2, and then SO4 gives us the sulfate. What's happened is that the CuSO4 has been reduced from Cu2SO4 2. So you always have to do that check to make sure that your ionic charge on your polyatomic is what it should be, just like before when we were looking at ionic charges of our nonmetals. Okay, so that concludes our lesson on naming and determining formulas for polyatomic compounds. So all you're going to have to do now is to do some practice until you get good at recognizing when you have a polyatomic ion. And then you can name it properly.